Dear students, myself, Mr. Umesh Rajendra Yevle, lecturer at Statistics Department, Pratap College, Amalner. Students, from today, we are going to start lecture series for SY students. So, from today, I am going to start lecture series for the course STMJ ST 241. The title of the course is Continuous Probability Distributions and Sampling Distributions. Continuous probability distributions and sampling distribution. So let's start the first chapter of this course. Univariate continuous probability distributions. Univariate continuous probability distribution. So students, in the earlier classes in 5AC, we have learned about univariate discrete probability distributions. So whatever the concepts we have learned FIBAC regarding the discrete probability distributions, same concept we will continue for the continuous probability distribution. So we know that one basic concept is sample space. But what do you mean by sample space? Sample space is the collection of, if we perform the experiment, then whatever the possible collection of, then the collection of all possible outcomes is called as sample space. Then on the basis of according number of elements the sample space, there are the two types of the sample space. One is discrete and another is continuous. Okay, so our interest for this chapter, our interest is in the continuous sample space. So what is mean by the continuous sample space? If the range or the set of possible elements of the sample space, if it is continuous, then the sample space is continuous. Similarly, we have also learned one concept, random variable. What is meant by random variable? So it is denoted by the capital letters and it is defined as, it is the real valued function. Okay. What is meant by random variable? A random variable is real valued function. So it maps, if we denote the random variable capital X, it is the real valued function which maps on which depends on omega and maps to R. This is the definition of random variable. Then for this random variable there is concept range set. Range set of random variable. So Range set means whatever possible elements in that range, that random variable, it is range set. Again, if it is discrete, then the random variable is discrete. If this range set is continuous, then the random variable is. And there are the two types of random variable. One is discrete, and another is continuous. Okay. So it is based on the basis of what is the range set of your random variable. That range set is continuous. The random variable is continuous random variable. So our interest is for whatever the definition or whatever the concepts we will learn in this chapter, they are all for this continuous random variable. Okay. So if you want to see some examples of continuous random variable, then common example, height of the students, weight of the students. So these are the examples for this continuous. What are the concepts we will learn for this chapter? Univariate continuous probability distribution. They are all for this continuous random variable. So let's start with the basic first concept, main concept of this chapter. Full form is probability density function. Probability density function. Okay, so this concept is as similar as of the concept of PMF, which we have learned for the discrete case. So any function fx is PDF. Again, this fx is, if it is defined for the continuous random variable x. Okay, then this is PDF if it satisfies the two conditions. First one is greater than or equals to 0 for every x, and second condition is uh, if we take the integration from for the entire range minus infinity to infinity, fx dx, it will be, so any function, continuous function fx, if it is defined for the continuous random variable x, is PDF if fx is greater than or equal to 0 for every x, for the entire range from minus infinity to infinity, fx dx, it should be 1. Okay, so this is the definition. With the help of this PDF, the PMF is provided. With the help of PMF, we can find out the probability at discrete points. Okay. On the same way, for the with the help of probability density function, we can find out the probability. But with the help of this PDF, we find out the probability for regions, not for the discrete point. So, we want to find out the probability. Suppose we have graph. The function is like this, and this point is A and this point is B. We have to find out this region. What is that region? Probability of A less than X less than. So how we will find out this region? So it will be uh, by taking the integration from this A to B x d. In this way, we have to find out the probability for the continuous, for the given function, continuous function. So since this function is continuous, probability of A less than X less than B is as similar of this one. Uh, Students, if this, in case of discrete distribution, all these probabilities are differ. Okay. Now since this is the continuous, it doesn't differ these probabilities. For continuous random variable, the probability of A less than X less than B, all these four probabilities computed by taking expression X. That's it. Now let's see some examples, basis of this concept probability density function. Suppose one function fx equals to 3x square 0 less than or equal to x less than or equal to 1 to otherwise. F of x is PDF. No. Suppose this function fx is given, is asked verify this function is PDF or not. This is PDF or not. Okay. So how we will verify this function whether it is PDF or not? There are the two conditions. First condition is this fx should be defined for all x. Okay. So clearly this fx is defined. No. First condition is fx positive. Now this function is defined for these values 0 to 1. If you put all these values, if you put 0, it will be 0. Fx will be 0. If you put the maximum value of x 1, it will be 3. And whatever the value in between you put in this function fx, you will get fx is equal to 3x square greater than or equals to 0. कुठलीही व्हॅल्यू तुम्ही या ठिकाणी या फंक्शन मध्ये टाकली तुमची fx ची जी व्हॅल्यू आहे ती काय येणार आहे पॉझिटिव्ह येणार आहे. So fx is greater than or equals to 0 for every x. The first condition is verified here. What is the second condition? Take integration from minus infinity. Solve this. Lower limit is 0, upper limit is 1, the x square dx the x square integration is x cube by 3 0 to 1. 3 get cancel. Put the values you will get. Clearly both the conditions are satisfied here. Fx is let's see some more examples. Now we will see one example where fx is k upon 1 plus x square minus infinity. This is PDF. Fx is PDF now. And they asked to find. Now since this is the PDF, so we will use the second condition that integration from minus infinity to infinity fx dx is to 1. Since fx is PDF, we can solve this. Just put the values minus infinity to infinity a upon 1 plus x square dx equals to 1. Take k outside. Integration of 1 upon 1 plus x square. We know that the derivative of tan inverse x is 1 upon 1 plus x square. So the integration of 1 upon 1 plus x square is tan inverse all this, okay, tan inverse of infinity minus to put the values, we know that tan of pi by 2 and tan of minus pi by 2. So tan inverse of infinity is pi by 2 minus minus of minus, that is plus pi by 2 is to 1 plus k into pi is to 1 plus k is equals to 1 1. So students, in this way we have to find out the value of k. Find out the value of k, we have to use the condition, we have to use the definition of this PDF. Now let's see the next example. Now in this third example we will find out the probabilities. जे आपण या ठिकाणी डिस्कस केलं बघा, की जर PDF दिलेलं असेल तर त्या PDF वरनं प्रोबॅबिलिटीज कशा फाइंड आउट करायच्या. तर इंटिग्रेशन A to B घेऊन त्या fx साठी probability of A less than x less than b is nothing but integrating A to B fx dx. On the basis of this note, now we will solve our next example. Fx is equals to 1, 0 less than x less than 1, 0. Find, suppose this fx is PDF, fx is, add here for the following. For the following PDF, fx is equal to 1, this, 0 less than x less than 1, 0 otherwise. Find probability of 1 by 2 less than x less than 1. Second, probability 1 by 2 less than x less than by 4 given x greater than. Okay. So how to find these probabilities? We will find these probabilities. Probability of A less than x less than b is equal to integrating A to b, that is 1 by 2 1 x integration 1 by 2 to 1. What is fx here? 1. Integration of 1 is x. Put the values 1 minus 1 by 2. Answer is okay. Now next one, second. Probability of 1 by 2 less than x less than by 4 given x greater than 1 by 4. How to find these probabilities? Suppose this part is A. This is probability of A given B. कसा find out करतात? We will find out probability of A given B by the formula probability of A section B divided by probability of B. So here A is 1 by 2 less than x less than 3 by 4 and B is x greater than 1 by 4. Just take integration part, sorry, intersection part. You draw this real line. This is by 4 by 2, this is 3 by 2. This is A. B is this one. This is 1. Intersection part is 1 by 2 to 3 by 4. A intersection B part is 1 by 2 less than x less than 3 by 4. Nothing but simply again A. So the probability of A given B is equals to probability of A intersection B. The intersection part is simply the greater part 1 2 less than x and 3 by 4 divided by probability of x greater than. Okay. So solve this. Probability of 1 by 2 less than x less than 3 by 4. How to solve this? Just take the integration 1 by 2 by 4 1 dx divided by integration from 1 by 4. Upper limit आहे या ठिकाणी, upper limit is 1. All this integration of 1 is x. 3 by 4 by 4. To solve this, 3 by 4 minus 1 by 2 divided by 1 minus 1 by 4. So 3 by 4 minus 1 by 2 is 1 by 4 divided by. So the answer is 1 upon. In this way we can find out this probability. We can add some more parts here. So suppose here a is 1 by 2 then or equals to x less than or equal to 1. याला a म्हणूया आणि b जो आहे x greater than 1 by 4 असो. So sometimes suppose a and b are just a आणि b आता आपण कन्सिडर करून घेतले आणि विचारलंय तुम्हाला फाइंड just find probability of b, probability of b, probability of a dash, probability of b dash. हे सुद्धा एक्झाम्पल्स विचारले जातात. Probability of a and b. Third one, probability of a intersection b, probability of a intersection b dash, probability of a dash intersection. So probability of a already we have computed. This probability of a 1 by 2 less than x less than 3 by 4 याची probability आपण काढली, ती आली 1 by 4. आणि probability of b म्हणजे b या ठिकाणी काय घेतला आहे x greater than 1 by 4. त्याची probability आहे 3 by 4. So the probability of a is by 4. Probability of b आहे probability of a dash. What is probability of a dash? It is 1 minus probability of a, 1 minus 1 by 4 by 4. Probability of b dash is 1 minus probability of b, 1 minus 3 by 4. So first part is over. The second part, it is as probability of a union b. So probability of a union b is equals to probability of a plus probability of b minus probability of a intersection probability of b, probability of b, the value is 1 by 4. Probability of a intersection b we have calculated here. Of intersection b, nothing but itself probability of a. So this get cancelled. Probability of a union b is by. Okay. Third one, in the third part they are asked to find out probability of a dash intersection b. हे काय विचारले, probability of a intersection b dash असे विचारले. तर probability of a dash intersection b dash याला लावलेले. So use the formulas. Probability of a dash intersection b is equal to probability of b minus probability of b is 3 by 4 minus probability of a intersection b is of a, which is nothing 3 by 4 minus 1 by 4, 2 by 4. Answer is 1 upon. Probability of A intersection B dash is probability of A minus probability of A intersection B. Probability A is by 4, intersection B by 4. This is 0. Probability of A dash intersection B dash means what? Is the probability of A union B dash. Nothing but 1 minus probability of A union B. 1 minus probability of A union B, we have just computed here by 4. This way, you can find out this. So, students, what we have learned today's lecture. This lecture we have discussed concept of continuous sample space. Then we have also discussed the concept of continuous random variable, and for continuous random variable, throughout the lecture we will discuss some concepts based on the continuous random variable. And today we learn the first concept, probability density function. Okay, so any function, continuous function fx is defined for the continuous random variable x. It is said to be PDF, it satisfies the two condition. If fx is greater than or equal to 0 for every x, over the entire range, integration from minus infinity to x dx is 1. Okay, we learn this definition. On the basis of definition, we solve first two examples. With the help of PDF, we can find out the probability. This probability of a less than x less than b, it is nothing but integrating from a to b fx dx. On this concept, on this note, we solve this third one. For this, for the today, stop here. The next lecture, we will learn the next concept for continuous random variable, that is the distribution function. So for today, that's it. Stop here. Thank you.